I'm back. I hope you tried the assignment I gave you. If you have not seen Fractions, Decimals, and Percents Part 1, please go back and look at those. I like to do review, and I'd like to review everything I've gone over, but I think that it's necessary to go right on, jump right in, and the assignment I assigned was to see if you can tell what value you need to think of for 25ths in order to convert them. Well, let's say I have 7 25ths, which happened to be my first example that I gave in the first video. Well, I was able to do this very easily in my head because I know that 25 times 4 makes 100. And 7 times 4 makes 28. That gives me 28 over 100. We can read that 28 hundredths. And when we read a decimal, this decimal is literally read correctly as 28 hundredths because this is the tenths place. Tenths with a TH, sound like Sylvester. Hundreds. With that TH at the end. This is 28 hundredths. It's also read 28 cents. We've seen this written in dollar notation as 28 cents. I can write this as 28 cents. I can also write it as 28%. Perfectly acceptable. They all mean exactly the same thing. There is no difference between this symbol and this symbol mathematically. This is 28 cents, 28%, 28%, 28 cents, 28 hundredths, or 7 25ths. They are all exactly the same. This is an equivalent fraction. I multiplied by 4 over 4, which is 1. And 7 25ths times 1 is 7 25ths. Or in this case, 28 hundredths. The same thing. Let's look at another 25ths. How about 13 25ths? Problem we run into here isn't the difficulty in understanding the question, it's the difficulty in multiplying by the factor that you want to multiply by. I'm going to change my 25ths to hundredths by multiplying by 4. Now the way I taught in the first video how to change this is to think of 25ths. Rather than thinking of 25ths as a fraction and having to multiply them on paper, I like to think of them as 4 cents. They have a value of 4 cents each. So if I have 13 of them, I multiply the 13 by 4 in my head, and I get 52. That's 52 cents. I can write it like a decimal. I can also write it as a fraction. 52 cents, 52 hundredths, that's 52 hundredths, but I can also write it as 52 cents. And the cent is the same thing as the percent, 52%. I can even write it with the words. I can write 52%. All of these things are mathematically equivalent. And we need to be able to work back and forth between fractions, decimals, and percents to be able to solve problems in English. That gives us our 25ths. We can use the same idea to work with our fifths. And again, a part of the assignment that I asked you to do was to think of the number that you need to multiply by 5 to get 100. The hint, of course, is staring us in the face. We call this particular thing conjugates. Notice that 20ths were 5 cents each because 20 times 5 makes 100. So fifths are worth 20 cents each. So if I have 1/5, I have 20 cents. Or 20 cents. Or 20%. Every fifth is worth 20%. So if I say 6/5, notice I have more than one. Again, if you want, you can choose to turn this into a mixed number, but I prefer just do it in my head. 6 is worth 20 cents each, and if I have 6 of times 20, I have 100 120 hundredths, or 120 cents. That is 120%. One last one. Let's do 11 fifths. Looks a little scary. It's not that bad though. You see, 5 goes into 11 2 times. So I have 2, and I've got a fifth left. 2 and 1/5. And again, change that to a mixed number. And if you ever happen to see 2 and 1/5, realize that you're looking at 2.20, $2.20, or 220 hundredths. That is 220%. So my fifths are worth 20 cents each. As a conjugate, we have fifths are worth 20 cents, 20ths are worth 5 cents. Let's put a 20th problem on there. I'm going to put it right next to the fifth. If I write 1/20th, in order to multiply 20 times a number to get 100, I need to multiply by 5. That means that 20ths are worth 5 cents each. I can write it like this. I can even write it as nickels. So each 20th is worth a nickel, each fifth is worth 20 cents. We're almost done with the money. And I hope that you can see that this is a little easier than you may have thought before. Hopefully you're making some connections. I hope you were able to make your own connection with the halves. By the way, this is a half $1. That should give you a big hint, and you can do it yourself. To do these others, I'm going to save the easiest one for last, and you'll have to guess which one that is. One of the harder ones are the thirds, and people have a lot of trouble with these. Part of the problem is that it's called a repeating decimal. And 1/3, one way to write it is to write it as a repeating decimal. It is 0.3333, and it keeps going forever and ever and ever and never ends. That does not make it an irrational number. This is still a rational number because you can write it as a ratio or a fraction. But it's pretty ugly when you try to put it in your calculator. In fact, the only way to put a 1/3 into your calculator is to put it inside parentheses. If you happen to have a calculator and you want to put 1/3 in it, you have to type in parentheses 1 divided by 3, close the parentheses. If you put 0.33333, you're only getting an estimate. You can't write the 3's forever. Now that leads us to another problem. If I have an infinite number of 3's here, I certainly can't write it as a decimal percent. The way to get around that is to move the decimal 2 places to get our percent. That's 33% is really close, but it's not exact because it's really 33.333333%. Well, that 0.333 is 1/3, so we write it as 33.33%. If any of you who are watching this are over 50 or so, you're going to be very familiar with this particular number because that happens to be the speed that was on your record player. For those of you who are a bit younger, you're just going to have to memorize 33.33% is 1/3. It means the same thing. The good news is the third is out there. Now, the one everybody has trouble with is the 2/3. But I'll give you a hint. People have a devil of a time remembering this. It's one way to remember it. Another way to remember it is to think of if 1/3 is 0.33333, 2/3 is twice as much. That is 0.6666, and so on. And you may have thought that it's going to be 66 1/6%, but it's not. You may have made that prediction. It's actually 66.66666%, and that's 66 2/3%. Now that leads us to one more, and this is the most difficult. I'm going to do 4/3. And in this case, you really do need to think of this as a mixed number. It's 1 and then 1/3 more. So I'm looking at 1 and then 1/3, which is 0.333, and so on. One way to write a repeating decimal is like this. Another interesting way to write a repeating decimal is with a bar over the 3. So I can write this 1.3 with a bar over it. Well, that's kind of a hint, because look at this. Doesn't that look like a 1 and a 3 with a bar over it? Look at that. 0.33333 is 0.3 with a bar over it. Looks like it's almost there. That is 1, 3 with a bar over it. How about this one? 2 3s with a bar over it. Some of you may have seen 3 3s with a bar over it, and that's a bit scary. I'm going to address that in my pre-cal lessons, and the reason is it's a little beyond the scope of decimals, percents, and fractions, but it just so happens that this number is exactly equal to 1, which is counterintuitive, but it actually does work out that way. If you get a number that's small enough, it's actually equal to 0. A lot of heavy-duty math in there, but for those of you who like to think a little bit, you can play with this a little bit and think about why that's true, using your thirds. That deals with our thirds, and you're going to have to memorize them. There's no real way to get around it. I don't think you really want to do the division. You can. And in fact, for all of these problems, every single one, the 1/3, 1/4, 1/5, 1/8, 7/25, all of them, they literally mean a division mathematically. You see, 1 over 3 means 1 divided by 3. Now be careful. You don't automatically put the big number in here. The number in the numerator goes inside the division. We're talking about 1 divided by 3. And I can do this division. You look at this and you say, my God, how do you divide it? 3 doesn't go into 1. So I have a 1 remainder, I get 1/3, there's no dividing. Well, what you do is you include the decimal. And we write the decimal straight up, and we ask ourselves the question, how many 3's go into 1? Happen to be 0 3's that go into 1. And I have a 1 left over. Then we include an extra 0, in case you've forgotten. 3 goes into 10 3 times. 3 times 3 is 9. And we subtract. And we subtract these and we get a 1. Now a lot of people are going to be tempted to say, the 1 goes here and I'm all done. But unfortunately, the remainder does not represent a decimal. To get the next decimal, you have to include another 0 and bring it down. And hopefully you can see that 3 goes into 10 3 times. And 3 times 3 is 9. And we subtract and get our 1. And according to iteration, this is going to continue forever and ever and ever without end. So I'm going to have 3 and 3 and so on. That's where my 1/3, that's another way to get it. You certainly don't want to have to grab your calculator every time you see a 1/3 and divide it. You certainly don't want to have to grab paper. So you want to memorize that 1/3 is 0.33333. We have one more that you need to memorize, and this, well, actually 2 more. The sixths are one that I like to memorize. And if you'd like to, it's a good practice to go ahead and do the division on the side. You're dividing 6 into 1, and you can do that division. By the way, your paper usually has a margin on it. There's a blue line, or rather a red line on most paper. And there's a margin. Well, that margin is actually used for something. Let's use it to do some notes. I'm going to take 6 and put it into 1 in the margin. And if you'd like to do that, you will get your decimal. Again, a good idea is not to watch these like a cartoon, but to actually pause them, try a little bit on your own, maybe do this division, and try to remember this pattern. It does have something of a pattern to it. I'm going to continue. Hopefully you can use the pause button. Hint, hint. 1/6 happens to be 0.16666, and the 6 continues, not the 1, and not the 1/6. And if I move the decimal 2 places, 1, 2, I'm going to get 16.66666%. And you're going to be very tempted. I can actually write a bar over this. What you're going to be tempted to do is write 16 and 1/6%, just like you wrote 33 and 1/3%. Unfortunately, 0.6666 is not 1/6. 0.166666 is 1/6. This is 16 and 0.6 is 2/3. There is no real good way of doing this except to memorize it. And I'm going to teach you some methods of memorization, and it's actually a method of remembering rather than memorizing, but we'll get into that. The other one that you have to worry about is 5/6. You don't have to worry about 2/6 or 3/6 or 4/6. And I want you to think about why that's the case. Write 2/6, 3/6, and 4/6. You have already written all of these fractions, their decimals and percent equivalents. So you don't have to worry about those. 5/6, you're going to have a guess. You may, according to this, look at this and guess it's 0.5666666. That would be very nice if it were. It's not. I'm sorry. A really good exercise for you is to go ahead and do the division on the side. Pause the video and give it a try. Seriously. It happens to be, I hope you got it, 0.8333, and so on forever. And that is 83.3 repeating percent, or if you like, 83 1/3%. That's 5/6. Now if I get into the bigger sixth, it gets a little more interesting. For example, 7/6 is 1.1666, and so on, or 116 2/3%. I will be using this particular example and some others to show you a few methods for memorizing, remembering, and making connections on your own. I'm going to continue this video in just a little bit. We've done the 6th. I think I'm going to do one more. We'll go ahead and do the 8ths right now, and then I'm going to show you the memorization technique that I promised earlier. There is a pattern to 8ths, and by remembering the pattern, we can remember the 8ths. And here they go. 1/8. I don't worry about 2/8. 3/8. I don't worry about 4/8. We already know these. If you're not sure, reduce the fraction. That's the hint. 5/8. I don't worry about 6/8. And 7/8. There's a pattern. It's not mathematical, but it helps you to more easily remember the decimal equivalents for these. Now something I'm going to tell you, it's a secret in mathematics circles, when people give you a standardized exam, they love 8ths for a lot of really good reasons. One of the reasons they like 8ths is because they're not a repeating decimal, which can get can bog people down, especially if they're doing estimation. They're a really nice decimal that ends in the thousandths place, and they always end in a 5. That's something you can memorize. And for that reason, they're used often in standardized exams. And by knowing these equivalents, you're going to speed up your standardized exams. An example would be, I saw probably 7 to 10 eighth problems on the FBI exams. They're a system of about 6 or 7 exams. Takes all day long, and there's a lot of eighths involved in those. They also include them in the SATs, the GREs, if you can imagine, all the way to the graduate record exam. They're still using eighths in their standardized exams. Of course, in the AccuPlacer, your goal may be to get out of remedial mathematics, and I hope to help you with that. One of the ways of getting out is to be able to know these equivalents, and they will help you to speed it up a bit. So here we go. Here is a pattern. 0.1, 0.3, 0.5, and 0.7. Now this is only a pattern, this is only a trick. It will help you to be able to do eighths and to remember them more easily. Eighths are related to quarters or fourths because 2 eighths is 1/4, which is 25 cents, 25%. 4 eighths is 2 quarters, which is 50 cents. It's also a half, which is 50 cents. 6 eighths is 3 quarters, which is 75 cents, or 3/4 if you like. And all I need to do to get the rest of the decimal is to ask myself, what is 1/4? It happens to be 25 cents. Now this is not in the hundredths place, so it's literally not 25%. This is not 125%. This is 12.5%. If you can see, the 12 is in the hundredths place. That's 12.5%. So be careful. This is not the same as 125%. 3 quarters makes 75. That's how I remember that that's what goes there. Now it gets a little bit tricky now. 5 quarters is $1.25. That makes this a 6. And I told you there's a pattern. It's not necessarily mathematical, but it will help you to remember it. I want you to think about what I just did here and try it yourself there. If you need to, pause the video, give it a try. If you wait for the answer to come to you easily, it won't. A lot of mathematics is struggling to find an answer and find your own answers to your questions. What I'd like you to do is think of this pattern, see if you can anticipate what this is. If you absolutely can't get it any other way, you can always do it the hard way and take 7 divided by 8. And I'll put that on the side. Get it all prepared. 7 divided by 8. Now before I move on and before we leave, I am going to go ahead and write the percents of these. When you write a percent, we move the decimal 2 places. That is 12.5%. That is exactly equivalent to 12.5%. Either one of these is perfectly appropriate. This is, of course, 37.5%. And I'll leave the rest up to you. We've handled all of these except the ninths. And when I come back, I'm going to finish this up. I'm going to do a quick review of the whole idea, and then I'm going to show you how you can study to become better and better and better at these. Thanks for watching, and I'll be right back.